So we're talking about piecewise functions, which is just a big fancy math term for saying we're literally going to take pieces of separate functions and graph them together. Kind of makes sense, right? So pieces of functions all graphed together. The biggest thing that we have to pay attention to is we know functions can't share x values. Each x has to have a separate y value. They can't overlap, right? We don't want them to fail the vertical line test. So because we're going to be picking out pieces of these functions, we have to make sure that our functions, we're not drawing too much of one piece and it's overlapping with the other function. So we're always going to check to make sure our pieces do not overlap. If they're overlapping, then they're not a function. No, it's all yours. So with your first sticky graph, we're going to graph x plus 2, but only when x is less than 1. So this is the equation we want to graph. So they're going to tell us which equation to graph. And then they're going to tell us what numbers to plug in, because we're not going to use the entire graph of x plus 2. So we want to graph x plus 2 for all x values less than 1. So the first thing I always do is I look at my x is less than 1. I look at this piece here. And I go over to my graph and I draw what I'm going to call a fence to tell me where to stop my graph. So I'm going to go to 1, since x is less than 1, on my graph. And I'm just going to draw myself a dashed line all the way up and down where x is 1, so that I know as I'm graphing, I'm not crossing over that line. I don't want to extend farther than that line because I don't have those pieces of the graph over there. So I kind of just do that for myself as a reminder of where I need to stop. After that, I'm going to make a table because personally, it's just easier for me to always make a table, plot the points, and connect the dots. Just works every time. So I'm going to make an XY table. And even though my graph says x can only equal, it has to be less than 1, it can't equal 1, I'm still going to use 1 in my table. And then I'm just going to put an open circle when I plot that point. But I want to get my graph to go all the way up to my fence. So I want to make sure that even though it's not an equal to sign there, I'm still putting 1 in my table. Then I want numbers less than 1, so I'm going to go with 0, -1, -2. As long as you have about 4 numbers in your table, you'll have enough information to get yourself a picture of the graph. If you want to be more thorough and you want to put more numbers in there, you definitely can, but I would make sure you have 4 in there just to make sure you can get a good idea of what's going on. So then I'm going to plug in my x values, right? So I'm going to plug in 1, and I'm going to say, okay, I have 1 plus 2, which gives me 3, right? So then I'm going to do that for 0. I get 0 plus 2 is 2. -1 plus 2 is 1. and negative 2 plus 2 is 0. And I just plugged into here. I plugged into my x value in order to get those numbers. And now that I know those numbers, I'm just going to plot those points. So I'm going to go to 1, 3, and plot a point. I'm going to go 1, up 2, 3. I know that this has to be an open circle there because it's just a less than sign. It's not equal to. I knew I couldn't include 1. Then I'm going to go to 0, 2, and plot that point. And then negative 1, 1, and 2, 0. And I see that I have a line just going like that. So now I only have to worry about using an open or closed circle when I'm on the actual fence. All the other points that I'm plotting are always going to be closed. So only use open, closed circle on fence. All the other points that I plot are just going to be normal. Why will this not go away? What if I spiced it up a little and I gave you x minus 1 all squared for all x values greater than or equal to 1? So the first thing you want to do is go and put your fence in. Where am I going to build my fence?
1.
At 1. And I know that because I'm looking at the number in my inequality. The number in my inequality tells me where to build my fence. So I'm going to build it at 1. I'm just going to draw in a dotted line for myself. And since my inequality says x is greater than 1, I know all of my graph is going to be on this side of my fence. I'm only on the right side this time. So now that I've built my fence, I'm going to make my table. I always use my fence as my first number in my table. So whether it's equal to or not, that's always going to be the first number. So I'm still starting at 1. But this time I want numbers bigger than 1. So I'm going to do 2, 3, and 4. And then in order to get my y values, I'm plugging in to x minus 1 squared. So when I plug in 1, I do 1 minus 1 gives me 0. 0 squared, still 0. Then I'm going to plug in 2. 2 minus 1 gives me 1. 1 squared is 1. Then I'm going to plug in 3. 3 minus 2, or hello, 3 minus 1 is 2. 2 squared is 4. And then plug in 4, I get 4 minus 1 is 3. And 3 squared is 9. So now when I go to graph this first point, do I want an open circle or a closed circle? It's going to be closed because it's a greater than or equal to. That equal to tells me closed. So I'm going to go to 1, 0. And my first point that I plot this time is going to be closed. Then I'm going to 2, 1, 3, 1, 2, 3, 4. And 4, 9 isn't even going to fit on my graph. It's going to be way up here somewhere. So I have what looks like a piece of a parabola. And I kind of knew I was going to have that because I recognized that it was an x squared. Once I've got my piece of my function, then I'm all done. Are you ready to use your fancy colors? Yeah. Okay. Well, you could have been already using them, but here's where you really need them. So, okay, feel free and toss out whatever one isn't working for you. So, number 3. All of a sudden, we're going to step it up a notch. Here's where you're going to use 2 different colors. So, when you write this down, I'm going to use, I don't think you're going to be able to see this blue, so I'm going to use a different color. I'm going to use orange. And I have x plus 2. I'm going to graph in orange. And x squared, I'll do in blue. So when you write that down, you want to use 2 different colors because we're going to graph 2 different graphs on the same thing. So now, we've already graphed both of these. We already looked at x plus 2 when x was less than 1, and we looked at x minus 1 squared when x was greater than or equal to 1. But when I write a real piecewise function, I'm normally not just going to use one little piece of one function. I'm going to use little pieces of a bunch of different functions. And the way they tell you that it's going to be all together like that is that big bracket that kind of chunks them all into one y equals. So that big bracket tells us that we have lots of different pieces of graphs going all on the same grid. So I'm still going to do same things. I'm going to go in and I'm going to draw my fence first. So I'm going to look at my inequalities and I notice that they both have a 1 there. In order to be a function, that number is always going to be the same because I'm going to be using one function up until 1, and then I'm going to switch and use another function after 1. So I'm going to go in and draw my fence at 1 because that's going to remind me that my pieces can't overlap or cross that fence. They have to stay on their own side. And then I'm going to look and I'm going to say, okay, which piece goes where? I have x plus 2 when x is less than 1. So since it's an x plus 2, x plus 2 is going to go on this side because these are the numbers less than 1. X minus 1 squared is going on the right side because those are the numbers bigger than 1. And I'm getting that by looking at the inequalities. The inequalities told me what side to pick. So then I'm going to make a table for each of those, and then I'm going to plot them. Good thing is we already made those tables, right? I made my table x plus 2, my x, and my y table. For x plus 2, I used 1, 0, -1, and -2. And I had 3, 2, 1, 0 when I plugged in. And then I need to make a table for x minus 1 squared. And I used 1, 2, 3, and 4 for that, which I got 0, 1, 4, and 9. So normally we're not going to graph both pieces separately before we actually graph the piecewise function. So normally I'm going to be plugging into those tables for the first time to get those numbers. Once I get the numbers, I always like to tell myself which one's going to be the open circle and which one's going to be the closed circle. So I look back before and I label them and I say, okay, I see that x minus 1 squared is going to be a closed circle. And I know that x plus 2 is going to be an open circle. I just like to remind myself so that I don't accidentally put the point in the wrong place. And then I'm going to graph it. So I'm going to go over to 1, 3, which now I know 1, 3 has to be an open circle, so go over 1, up 3. And I'm going to draw my open circle. And then I'm going to plot my other points, 2, 0, negative 1, 1, negative 2, 0. I draw my line. And I'm going to do the same thing for my other table. So I'm going to go 1, 0, and 1, 0 gets a closed circle. And then I have 2, 1, 3, 4, and I connect those points too. And once I've drawn my entire graph, once I've drawn all my pieces, I'm done. So you're gonna get really, really weird looking things that you're not used to because we're just using chunks of graphs. They might connect, sometimes they may end up overlapping, or they might look like this one where they're completely separate pieces. If they overlap, the closed circle always wins. So if you have an open circle for one and a closed circle for another and they're on the same point, the closed circle always wins. Yeah, it's always closed. Not bad. So if you wanted actual steps for yourself in case you were a little bit lost in the sauce, or if you get home and you might be lost in the sauce, the first thing you're going to do is you're going to build your fence. And your fence is always going to be the number in the inequality. So the first thing you're always going to do is build your fence right at the number in the inequality. I wish this silly little record box would go away. I don't know why it's doing it. Then you're going to look at the inequality and decide who owns the fence, who has the open circle, who has the closed circle. And you were good at that. You remembered that these symbols get open circles. Whereas the equal to symbols get closed circles. Whoever has the closed circle technically owns the fence because they're the one that exists or can live on the fence. Then you're going to make your tables. You always want to make sure when you make your tables that both tables have your fence number in them. So whatever number is on your fence should be the start of both of your tables. And then you're just going to apply your points. So now you can have situations where you have more than 2 pieces. You can have, technically they could give you as many pieces as they wanted. For the most part, just to keep our sanity, we're not going to do more than 3 because it just starts to get a little ridiculous. But if you have more than 2 pieces, you're going to have multiple fences, which you'll see there'll be more numbers in your inequalities. Like if you had 3 pieces, there's going to be 2 different numbers in your inequalities to break the graph into 3 chunks. So you'd have 2 fences, and then you make a table for each piece of the graph. So if you had 3 pieces, you should make 3 tables. If you had 10 pieces, you make 10 tables.
So when we do like the arrow, how do we know like which ones don't get arrows? Like your starting point, do you ever put an arrow?
No, because the arrow tells me it keeps going forever.
So it's only for the end.
So only for the ends, because you can't cross over that fence. So you don't want to put an arrow next to your fence or pointing towards your fence, because that means it's going to keep going and cross over it, and we don't want it to do that. So only away from your fence gets arrows. Can I change this? You've got it written down? Cool. All right, let's do one more together. Let's look at y equals -3 when x is less than or equal to -1, and negative x squared plus 4 when x is greater than or equal, or greater than -1. So if you liked having your colors, feel free to do that again. Make one graph one color, the other graph another color. If you're just going to be a standard mathematician with your pen and your pencil, that's totally cool too. So first I want to build my fence. Where do I want to build my fence? -1, right? So I'm going to -1, drawing in my dotted line. I'm going to make -3 be this pretty pink color. And I'm going to do negative x squared plus 4 in blue. Where should both of my tables start? At -1. They're both going to start at -1. Even though -1 is only being included in the first equation, I still want to use it in both because I still want to get my graph really close to the fence, or as close as possible to the fence, so I know where it's going. And then I just use an open circle for my second equation. So they're both going to start at -1.
What if both of them have the equal sign?
That's fine. Then they both get a closed circle. Then, in order for it to be a function, though, those points should have the same y value. Otherwise, it's not going to be a function because you'll have 2 separate y values at an x value. Yeah. So now for -3, I want numbers less than -1. I'm going to do -2, -3, -4. What are my y values here? What happens when I plug in -1?
You add it or subtract it, right?
Is there anywhere for me to plug in the -1?
No.
There's no x there, right? So, lucky me, I jump for joy. That means every single y value is -3, no matter what. Woohoo! Nothing I have to do. They all have to be -3. I don't even have to think. There's nowhere to plug it in. This is where everybody normally panics because it was too easy and they were overthinking it. Then for my blue one, I want numbers bigger than -1. So 0, 1, and 2. And here's where everyone forgets to use protection. Yeah, and bad things happen. Order of operations tells me I have to square the number first before I multiply. Exponents before multiplication, right? So when I plug in -1, I'm taking -1 and I'm squaring it, which gives me 1, right? And then multiplying by the negative. So it's still -1, right? Because -1 squared gives me 1. 1 times a negative is -1. And then -1 plus 4 gives me 3. Do you want me to write that out so you can see what I'm talking about? Or did you follow that? You followed it? Okay. So if I plug in 0, 0 squared is 0. -0 doesn't exist, it's just 0, right? Plus 4 is 4. When I plug in 1, I get 1 squared is 1, times a negative makes it -1, plus 4 gives me 3. And then when I plug in 2, 2 squared is 4, times a negative is -4, plus 4, 0. If they wanted that negative to be squared, they have to put parentheses around the -x. So if they wanted you to actually square that negative sign, there would be parentheses protecting it. That's where the protection comes in. There's no protection there, so you just leave the negative off to the side. You use it afterwards. All right, so now I've got my two tables. I got to graph them. When I look at -3, is -3 getting an open or a closed circle? Closed. So this one's going to be closed. So when I go and graph -1, -3, I'm getting a big old closed circle. Then I'm going to graph -2, -3, -3, -3, -4, -3. My blue function, my -x² plus 4, this is getting an open circle. So I'm going to go to -1, 3. And put an open circle. Then I'm going to go 0, 4, 1, 3, and 2, 0. And I've got my graph, I've got my two pieces, I'm good to go. So now the last thing that I can ask you, and I'm going to ask you on your classwork today, is to evaluate the function, which you know means to plug in the x value. So if I'm going to evaluate the function, I'm plugging in the x value, but now when I look at that function, I have two separate pieces. So before I can plug in, I have to decide which piece to plug into. So I notice that x plus 2 is being used for any number less than 2. But then the second piece, that 2x plus 1, is used for any number bigger than 2. So when I'm plugging in, I'm not going to plug into both. I'm only going to get out one answer here because it's a function. I know I can only have one y value. I have to decide where to plug in. So I look at 0. This first one wants me to plug in 0. And I say, okay, is 0 less than 2 or is 0 bigger than 2? 0 is less than 2. So because 0 is less than 2, I'm going to take that function x plus 2, and where my x was, I'm going to replace it with a 0. So I do 0 plus 2, which gives me my answer of 2. I don't have to plug into that second piece because 0 is not bigger than 2. So it doesn't apply there. So you use your inequalities, tell you which one to plug into, and then once you decide which one to plug into, you plug the number in. If I want to plug in 2, I notice right away that both of my inequalities have a 2, but which one includes 2? Which one allows us to be equal to 2? The second one, right? This tells me that I can be equal to 2. So I'm going to use the second one to plug in 2.
Hello?
Hi.
Hi, can you do your attendance?
Oh, sure.
Next time there's going to be a consequence.
All right. So then I'm going to plug in. I'm nervous. I can't do the attendance. We're in the middle. We're almost done. Then I'll do the attendance. All right. So if I plug in 2, what do I get? Ooh. I get 2, right? Times 2 plus 1. 5. What happens if I want to plug in 4? Which one do I use? The top one or the bottom one? Bottom, yeah. So 2 times 4 plus 1, 9. So if they ask you to evaluate, you pick which one to plug into and then plug it in. You're still only getting one answer. If they ask you to graph, you're a professional at that now.